Hello and welcome to my channel Plasmatone. This is the video channel to my website www.plasmaspeaker.de. My name is Ulrich and I like to introduce you to my channel today. So this is the first time I make an English spoken video. I'm not a perfect English spoken man. I'm a lifelong radio electronics technician. I'm now retired and I spend now my time to repair old hi-fi equipment, and one of my favorites are plasma tweeters, so I decide to make a few videos about plasma speakers because they are not so common in these days now. Okay, so join me. I will today make a new plasma speaker out of my old Technac plasma speakers, which I showed several videos ago, I think a few weeks ago. These were old plasma speakers made by Torolf Hartung. It was a German who made music equipment in the 70s and 80s. And I think these are copies from plasma speakers from Otto Braun. Otto Braun was a guy who developed the first plasma speakers in Germany. He is the inventor of the Corona plasma speaker. And Otto Braun itself, I think these plasma speakers from him are clones from the Dukane Ionovac. So they are similar in circuitry and also similar in the mechanics. Okay, so join me. Today we are building Ionovac Replica out of parts of the old Technac plasma speakers. Enjoy! So these are the finished products. These are replicas from the Dukane Ionovac. So, and the horn is from the Technac plasma speaker. I stripped off this ugly blue paint which was on and painted in this brown color like also the Dukane Ionovacs were. And this is the case. So these are not finished yet. This is the process which I will show you, and we make this like the originals, like the original blends. So here comes the tube in a 6DQ6. I'm looking just if I had, yes, here's laying one around. So original Haltron, new old stock 6DQ6, English manufacturing. That goes in here. So, and here we need this ceramic spacer, goes in here with quartz cells. I have new quartz cells here. These quartz cells are produced according to the original specifications, and also got some electrodes here which are made out of Cantal. So these are also electrodes according to the original specification, and with that it goes in here. So these are the ceramic spacers with springs. So we took our quartz cell which goes in here, and these are the parts for the main parts for our speaker. So we have quartz cell electrode, the coil and the tube, and we make then the wiring. This speaker is already finished, and after this will make the power supply. So we are starting now building the cage, building the chassis, and have a look. So guys, now we are back in the electronics shop. I don't want to show you the whole process in case building. I think video case building is boring. So I like to build now the electrician part here of our oscillator case. And these are all the parts we need. 2-3 resistors, some caps, and a few wires. That's all. So at the end here we have caps which are going through the case. I don't know the exact word in English for this. These are caps. Yeah, I have here this thing. These are caps which are between this wire which goes through to the screwing attachment here, and they are rated 1 nanofarad. So this is this post, and if you look here, what is here built in, here is one post that I have stripped off the cap. So this is the post for the modulation. We don't need a cap with non-nanofarad on the modulation to ground, so this shorts your modulation. So this post is without a cap to ground. Yeah, okay, so I think we are starting with okay, the plan. The plan is here. The plan is the original Ionovac plan from Dukane. This is the oscillator part, and this is the thing we are building now. So talking about a little bit about that. So at first we need 2 inductors for the heater, and I use here a 56 microhenry rated 1.5 amps. Because the heater of the tube needs 1.2 amps, and therefore we need here inductors which withstand these 1.2 amps. So I have 2 inductors which are rated by 1.5 amp. So and now we have to build up these inductors according to the plan, from here to pin 7 and from here to pin 2. These are the 2 heaters. And pin 7 is then with a cap 2.2 nanofarad going to the chassis. So pin 7. So we are counting clockwise if we are looking from underneath. 1, 2, 3, 4, 5, 6, 7, 8. So according to the plan, the 8 is free. So this is the 7, and from the 7 we need one cap to the ground. So I think this is what I'm placing at first, because if we have the inductor mounted, it's ugly to get these caps to the ground. So pin 7, we have here a ground post, so first I solder the cap to here. Oh, the soldering iron is cold. What's going on here? Ah, it's getting back to life. Okay. So for soldering, you need soldering water. Soldering water, it's light red wine. So cheers. Italian light red wine. Ice cold. Okay, this is pin 8. Goes to the ground. So, oh sorry, not pin 8, pin 7. Pin 7 to the ground. So from pin 7. So sorry guys, I count wrong. This is pin 1, not pin 8. So we have here pin 7 connected to the ground. That's okay, that's according to the plan. And from yes, pin 7, pin 8. From this it's going to the ground, the cap. And now we have the 120 ohm, which is going to our pin 2. Now from our pin 2, pin 8. Often I see guys, they are wiring, so to say, pretty. So they make nice shapes, bound them correctly and make all this pretty. You can do this if you are working on normal AF equipment, so amplifiers and so on. Here we have an RF equipment. So here is high frequency. And in high frequency equipment, we are always wire as short as we can. So this is the difference between wiring in RF equipment or in AF equipment. So then we have the first, according to the plan, this is the first cap we made to the ground, and this is the 120 ohms. And now from pin 2 outside we need a choke. This is this one. And we don't reach the pin 2. So we can use now a pin from the tube which is not connected. So internally not connected is this pin of the tube. Therefore we can use this for a post. By the way, this is also done by Dukane in the 60s. So this is the post for the heater. Here we have the coil which is rated 1.5 amps. And we are using now a post which is not connected on the tube. This is this one here. And what we have to make is a connection from here to here, and this we can be done with a little piece of wire. You can use any wire here. I'm using the silver plated wire because it's left. This is the only reason. So. So, and now we have the second heater. This is this one. This is pin 7. And there we need also a cap to ground. So this is going to ground from our ground post. .2 nanofarads. And we need a second coil. This Ionophone Principle is very old. So the inventor of the principle was a French physicist, Mr. Klein. He has his first prototype working in the 50s, and then he goes to America for building it. I don't know why. So maybe the companies in France were not interested. Who knows? So, and he goes to Dukane. And they were highly impressed by his presentation. And so Dukane started manufacturing the first Ionophones with the old principle, and they have done it like they have done transmitters in the old days, and transmitters, the difference between transmitters and the Ionophone was transmitters you want not that your transmitter is sparking. And if Ionophone must spark to make the tone. So this was the big difference, and this was the mistake they make, because the oscillator they designed was not reliable, because when the plasma flame starts to burn, it changes capacity of the oscillator, and so they run off in frequency, and when they run off in frequency they have not enough power, because there was then a mismatch between the coil and the frequency. So this was the first attempt, and it's called in the States the T3500, I think. Dukane's 3500, and according to what I'm reading in the internet, the press called it a brilliant failure. It was not so reliable. Okay, now we need the others. We need the anode, and we need the gate. So, and therefore we need as first our gate resistor. This gate resistor goes from the pin 5, which is there, to our common, to our circuit common, not our chassis common. So this is here. Again, we don't want to win the prize for our best looking circuit. Nobody sees it later because it's inside the cage, and the RF is traveling all over the place, and therefore we want to make short leads. So, by the way, these are 3-watt resistors. Something is wrong with my iron. Getting cold. I think the magneto is getting old on these VTCPs from Welle. Oh, here it comes. So 33 kilo ohms. Okay. And now we need from the gate a wire which goes later to our quartz cell. This is a little Teflon isolated wire I stripped off. You can choose any wire, but I stripped off coax cable. I show you here. This is RG174 coax cable, and I like this because if you strip it off, you have here the ground wire outside, which we can use later for our electrode, and we have a nice Teflon isolated wire. So this wire has to go up this way. So now Now we need our modulation. That's easy to do. So modulation comes, as I told you, from this pin without the cap. And have to go to modulation according to the plan, has to go to pin 4. 1, 2, 3, 4. One, two, three, four. Yes. So without a cap, we don't want to short our modulation to ground. This is a cold solder point. We want to make the solder points pretty. Now, so the last thing we now need is the high power HV anode voltage, which comes from here, and therefore I have a binding post here, and from this binding post we need a cap to the chassis ground. Yeah, the best way has to be to do it first, but it's okay, I think. I'm able to solder it here. Fine. Fine. And now, very important, this is our C1 here. This C1 is the cap. It's rated with 12 picofarad. This is the one which controls flame and flame size and starting. This is this cap directly before the coil on the other side. For good starting, you have to make it high. High means between 30 and 50 picofarad. This is for good starting, but as I mentioned before, if the tweeter starts, the flame itself has a capacity. So this doubles this. So if you have here 30 picofarads and the flame is burning, you have 40 to 50 picofarads. Then you have not enough energy in the cell and the flame is not big enough. If you make it too low, say about 3, 5, 4 picofarads, it will not start. So what they found out is 12 picofarad is the middle value, which is okay for starting and also okay for burning the flame. So my binding post has a ground connection here on the bottom end. And this I can use now for soldering my cap on. Here we are. So normally under high frequency conditions, if someone is looking this video and has a little bit knowledge, normally the best way is to solder directly here to the binding post. But I think with this low frequency from 27 megahertz it will be okay. So now we can make our connection here. We make it from underneath because here is directly the bottom of our chassis. Like this. Now we go here. So, and now the last part underneath will go here. Sorry, I think I have my hand in the picture, but it's more convenient for me. So, okay, this is all underneath, and now we need a wire for our voltage on the coil, which will be here. Just have a look how much we need. Oh, this must be perfect. So, I think this is the wiring according to our Dukane's plan. Let's check. I hope we can see this. So we have made now these. This is the first coil here. This is the second coil here. This is our cap to ground. This blue one underneath. So then we have the modulation comes in here directly to 4 without any cap or something like that. This comes directly in, goes directly to 4 pin. Then we have here from the pin 5 to our circuit ground. This is this point here, our 33 kilo ohms. Then we have on the pin 8 a cap. Then we have on the pin 7 a cap. It's for the heater. These are our heater coils. And this coil is the cathode resistor. It goes from the pin 8. Yes, 7, 8 to our virtual ground with the coil outside. So underneath we are finished. Going to the top. So this is easy. This is the high voltage which is going directly to our coil. I think I will solder it here. This is our old coil, or this is the old coil from the Technac tweeter. They are all similar, but you can wind it also by yourself. You need about 30 millimeters diameter and 20 to 22 windings, 1 millimeter silver plated copper wire. So this is a ceramic body because we are talking here about HF, and HF high frequency always need good material because bad material makes shorts between the windings. So this is why you often see ceramics. So now we need our tube, and I have pre-manufactured this. This is an RF suppressor. I think this is called in English. This is 47 ohm resistor with about 4 windings around, and these suppress harmonics because these oscillators which are free running tend also to oscillate in the VHF area, and this is what we not want because you lose energy. And this is the only reason for this coil. The circuit will also function without these, but you don't know if the tube is oscillating in another area. So this is the reason for this. And by the way, this is a fuse clip. So, and these fuse clips for American fuses, by the way, these fuse clips are very good for our anode caps. You don't need anode clips for dollars. These fuse clips cost cents. So now we have to make a connection from here to here. Fine. So, this is done, and now we need, looks good. So now we need the counter electrode for our cell. I don't know if I have one here. Let me have a look. I'm not sure. Yes, I have one here. So these are simple stainless steel. You have to use stainless steel because it's getting very hot. You see it here, this is a used one. It's blue. So the flame which is burning in these cells with the electrode is 1200 degrees Celsius. I think that's about 2400 degrees Fahrenheit. So, and therefore you need stainless steel material. So now where we are here. So this is also a stainless steel screw which I bored out to the 3.5 millimeter, which my electrode has in the back. So when the electrode stays here in, and with the spring it's pressed against. So, which is here the right one? The right side is this. Sure. Now we have here the springs going in like this. I think like so, we say in English. So we have the quartz cell and the electrode. We need it underneath. Sorry, I have my hands, cannot see it. So now we need one connection from the upper part of our coil to the electrode, and that's the reason why it's built directly under the electrode. It's very short. So this is the... So sorry guys, I didn't mention that the SD card was full and the camera shuts off. So yes, the Ionophone Replica is ready for the HF part. So we have built up the underwiring, we have built up this wiring, and yeah, it's finished. So we have now here two finished items. What to build now is the power supply. So I think the video is going too long. Therefore I decided to make a separate part for the power supply, and also with some explanations and testing. So for today I will finish this video. Thank you for watching, and we see next time. Bye.